We're back into the world of OOP in Dart. In the last video, we learned how to extend a class, or how class inheritance works. This time around, we are going to look at what is called a mixin, which is another way to reuse code across different classes and objects. But Jeff, we already know how to extend classes, you might be saying. Well, yes, this is true. But believe it or not, there are some situations where using the traditional class inheritance extension makes no sense. While it's true that extending classes offers you a tremendous amount of functionality and code reuse, sometimes mixins make sense and allow things to happen that normally couldn't. A mixin is a class that allows you to use attributes, variables, and methods from a class without having to extend it. This means mixins can be used in any class you see fit. This can make a lot of sense when you have functionality that you wish to share, but that doesn't necessarily make sense in the overall hierarchy of your classes. A mixin is defined just like you would define a class, but instead of the keyword class, you're going to use the keyword mixin. So we're going to call this mixin creating a mixin. And then inside this mixin, we're going to define one property, which is a string that says text, and it's going to say this is a mixin. That is how you create a mixin. You can do all of the same things that you can do in a class. You can define variables and methods. The one thing you cannot do is create a constructor. That is reserved for proper classes. So now you've created your first mixin. If you're like me, you're probably not understanding what they're for yet. So we're going to take a look at an example of when a mixin would be useful that should help you understand why they're used and what power they have. So I've gone ahead and created a class structure here. They're all empty because that's not what's important. We've got what is our base class, as we're defining it, called devices. And then we've got all sorts of different electronics that we're going to extend off of the device class. So we've got phone, camera, tablet, computer, VR headset, and a smartwatch. So these are all kinds of devices, but as your mind may already be seeing, these things have some very different ways of functioning, and they have different attributes. So let's go ahead and flesh out our device class first. So what might you want to put in the device class? Well, what things do all of these electronic devices have in common? This doesn't need to be an exhaustive or extensive list, but it does need to make sense logically for our purposes. So I thought that they all have a price, they all have a manufacturer, they all have a product name, and they all have a certain warranty period, so the number of years in their warranty. And as far as functions, they all do have some shared functionality. You can turn the device on, you can turn the device off, and you can restart the device. So these things will be usable in all of our devices. So every phone, camera, tablet, computer, VR headset, and smartwatch will be able to run turn device off, turn device on, restart device, and will have these attributes associated with it. When we create a class that extends another class, we need to have a constructor. And if you'll remember, in this constructor, we are requiring that price, manufacturer, years of warranty, and product name are set. So that means when we create constructors here, we also need to require them. When you're calling something from a parent object, it's kind of called a superclass. So when you see statements like super.price, all it's saying is that's coming from the parent class, which is commonly referred to as a superclass. So if you'll notice, I've created a constructor for each of these that takes price, manufacturer, years of warranty, and product name, because these are all required regardless of what kind of object you're creating. Let's take a look at creating some of these objects and seeing what kind of output we can get. So I've gone ahead and I've created a smartwatch called the Banana Watch. You can see the statistics I've set to it. 1 year warranty, $599.95, made by manufacturer Banana. I've made a computer called a Banana Book, product name Banana Book Pro, price $5,000, manufacturer Banana. And I've created the VR headset called Silly Face Goggles, which is made by Micro Details. And then we're going to issue some print statements, and then we're going to test the methods, turn device off, turn device on, and restart device. There's no reason to expect these things shouldn't work because we're not getting any errors in our IDE, and it all logically makes sense, but we always need to double check just to make certain. So as you can see, we're getting all of our data back in our command line terminal here, and all of the methods do appear to be working properly. So now let's go ahead and add a little functionality to the subclasses that we've created. We're not going to do all of these because that would take more time than we have today, but we are going to work on phone. Now if you look at phone, what kind of data or attributes might the phone have? We've decided it might have gigabytes of RAM, how many megapixels the camera has, how many cameras it has, the battery life in hours. And we've also created a few methods of common phone functions like send text message, take picture, make phone call, play a song. All very common things that are for the most part unique to a phone, although some of these aren't exactly. So now we've come back down to our main function and we've created a phone. and we've called it Robot Plus Phone. $499.95, manufactured by Krugel with a 1-year warranty, and it's called the Krugel Robot Plus. But look, now we have our new attributes. Battery life in hours, 1. That's not very good. Camera megapixels, 2. Again, not very good. Gigabytes of RAM, 8. Decent. Number of cameras, 2. Yeah, that's about standard. So now let's call some of our methods. Take a picture, play a song, and send text message, and make sure everything works. Okay, so as you can see, we took a picture, we played a song, and we sent a text message. Our phone is working, and so are the methods attached to it. If we were to go ahead and build out all of the other classes, multiple classes would have a take picture method. The phone would have one, the camera would have one, the tablet would probably have one. How would we deal with that? Well, the first option is we could duplicate this void take picture method in every single class. I don't really like the idea of us copy and pasting this code into multiple different classes. We could put the method in the devices class and then every device would have access to it, but that doesn't make sense either because the computer, the VR headset, and the smartwatch, for the most part, are not going to be able to take pictures. Well, guess what? This is where the functionality of Mixins comes into play. If you remember from earlier, you define a Mixin by using the Mixin keyword and then typing the class name. Now, if you'll notice, we added some new syntax here, which says on devices. This is not required, but it merely means that this Mixin can only be used on those classes. So if you have a class you really don't want to accidentally get used somewhere, you can use the on methodology. So you'll notice inside of this camera features Mixin, we've created our void take picture class. That's great. That means anywhere we use this Mixin, we're going to be able to take a picture, which allowed us to remove it from the phone class and to not have to add it to all of these other classes. So let's go ahead and scroll down, and I've created a tablet here called Robot Tablet, and I've created a camera called Tony A73. So let's go ahead and see if we have this take picture functionality available everywhere. If you'll notice, our Robot Plus phone still has take picture, play a song, and send text message, so we're going to call those. And then we're also going to try to take a picture on our Robot Tablet and our Tony A73 camera. Let's go ahead and run this file and see what happens. Wow, if you'll notice, it worked perfectly. We were able to take a picture with all 3 of those devices. So we were able to use this Mixin in the tablet class by saying with camera features, the camera class by saying with camera features, and the phone class by saying with camera features. All right, now how cool is that? This is a really great way to reuse code in a way that still lives within the object-oriented framework. We created a Mixin called camera features that could be used on multiple classes, and it allowed us to use that take picture method wherever we wanted to. Now let's go ahead and do this again for an exercise. I think some of these devices, but again, not all of them, have gaming features. So we're going to define a Mixin called gaming features. And once again, we're going to specify on devices, but you don't have to do that. What functions do most gaming devices have? They have the ability to install a game, play a game, uninstall a game, and rage quit a game. And each time one of these methods is executed, we're going to print a statement to the console so the user gets some sense of what's going on behind the scenes. So now that we have this gaming features Mixin, how are we going to use it? First of all, we need to decide which of our classes it makes sense to have gaming features on. Obviously, you can game on a phone. So you can see here, we have camera features and gaming features. So what else can play games? Well, camera can't play games, so we're not going to worry about the Mixin on the camera. Tablets can play games, so we're going to also add with camera features and gaming features. The computer can play games, so we're going to add gaming features with gaming features, because remember, to add a Mixin, you use the with syntax on a class. A VR headset pretty much only does gaming features, so we're also going to add with gaming features to the VR headset. I know technically you can probably game on a smartwatch, but really why would you want to? So we're not going to add it to smartwatch. So now we've got some devices that should have extended functionality, so let's go and test and see how they work. So we have the Robot Plus phone we created earlier. And as you'll notice, we're going to do some method chaining. So we're going to install a game, play a game, we're going to rage quit the game, uninstall the game, then we're going to make a phone call and text message and take a picture. I'm assuming we're probably making phone calls to our friends saying, why did you recommend this terrible game? Then we've got the silly face goggles, which is our VR headset that we've defined. We're going to install the game, play it twice. We're going to rage quit and then turn the device off. And then we're going to leave our tablet and our camera the same. Maybe we don't feel like gaming on the tablet today. Let's test and see if this works. You can see we have a lot of information in our command line here. Downloading a game, playing a game, rage quit this stupid symbols game, uninstalling game. Krugel Robot Plus is making a phone call. Krugel Robot Plus is sending a text message, taking a picture, downloading a game, and so on and so on. We have functionality that is exclusive to certain types of devices without having to use the inheritance class structure. There is some gray area about when you should use a mixin or when you should use a class. You're going to want to think about this in the overall design of your application, as we've tried to do so here. Where does it make sense where certain devices would have this and certain devices wouldn't? But mixins are a powerful tool. They're fun to work with, and they really allow you to create portable functionality that can transfer all around your application. Now we've learned what a class is, what an object is. We've learned what a subclass is and how to extend a class using inheritance. And we've also learned what mixins are. Now, there's still more to the object-oriented story, and we're going to get to those in future videos. For now, please, I implore you to practice these concepts as much as you can. Think of real-world objects and how you could create them in Dart using text representations in a class. Think of how you could extend that class. Think of how you could use mixins in that class. Do this as many times as you can, because once you really fire these synaptic networks in your mind, you're going to understand programming, specifically in Dart and Flutter, in a way that you never could have and never would have before. So take the time, don't just follow these videos, create your own things. I really hope you've enjoyed this. We're going to be back with more videos on OOP soon. Take care.